Okay, ladies and gentlemen, we're continuing here with section 3.1. I'm going to refer to this video as 3.1 part 2. Now you'll notice this equation that we're asked to solve. 3 is in one denominator, 2 is in another, and 6 is in the third, so my least common denominator would be 6. What I'm going to do is multiply through by the LCD. When I do the first, I'll call it building. When I multiply that by 6, I'm left with 2 times the quantity, k plus 1, which would give me 2k plus 2. When I multiply the next building, i.e. fraction, by 6, the 2 cancels into the 6, I'm left with a negative 3. And when I multiply the final building, i.e. fraction, by 6, the 6's cancel, leaving me with 3k minus 3. Okay, what I'm now going to do is to collect like terms on the left-hand side, which results in 2k minus 1 is equal to 3k minus 3. And I'm then going to rearrange the terms. I'm going to bring the k's to the left. I'm going to bring the numbers to the right, the constants. So that would give me a negative k, or opposite of k, equals negative 2. Now you can't stop here because that minus in front really means it's being multiplied by negative 1. When you divide both sides by negative 1, we come out with the answer k is 2. So the number 2 is called the solution of this equation. The set with the number 2 in it would be called the solution set. And this equation is referred to as a conditional because it has a finite number of answers. In other words, you can count how many answers you have. I have one answer. That is called a conditional. Now, the next equation is going to work in a very similar way. This denominator is a 3, this denominator is a 2, and we have no other visible denominators, so my LCD is a 6. But here's where my students get tripped up sometimes, is how many times to multiply through by 6. And the reason that the answer is 3 times, where I have the cursor right now, 2/3 times the quantity x minus 4 is not 2 terms, it's 1 term. 1/2 x is 1 term and 7 is 1 term. So when I multiply this first term by 6, what happens? The 3 cancels into the 6 twice. 2 times 2 is 4, and I then distribute the 4. 4 times x minus 4 produces 4x minus 16. Sometimes students say, well, what did you do to why didn't you multiply, 6 by what was in here? Technically, since it was 1 term, by multiplying it in front, we've taken care of that whole term. When I multiply 1/2 x by 6, it becomes 3x. 7 times 6 is 42. I'm down here to 4x minus 16 plus 3x equals 42. When I collect like terms, that becomes 7x minus 16 is 42. When I add 16 to both sides, 7x is 58. When I divide by 7, x is 58 over 7. 58 over 7 is called my solution. This equation is called a conditional. Now, there are sometimes special cases that arise when you're solving equations. For example, this equation doesn't look different until we get into it. I start off by distributing, that's pretty normal. That becomes 5x minus 10. And of course we have the plus 4 equals 5x plus 7. When I collect like terms on the left-hand side, or combine like terms on the left-hand side of the equation, it results in 5x minus 6, and this is equal to 5x plus 7. This time, however, when I start doing what's traditional, for example, reserving the x's on the left and the numbers on the right, look what happens. When I subtract 5x from both sides and I add 6 to both sides, I get 0 equals 13. In other words, my variables drop out. Obviously, something weird is going on there. If I asked you the question right now, wherever you're watching this, when is 0 equal to 13, I would hope you would tell me never. So that means this equation is never true, And if I take that one step further, that means this equation has no answers. So the solution set is the empty set. And there are two ways to write that. You can either write it with this symbol, or you can write it as a no solution. They both mean the same thing. This equation is not called a conditional because there are no answers. Remember, a conditional means there has to be a finite number of answers. This doesn't have any answers. This equation is called a contradiction, and that's because the left-hand side contradicts the right-hand side. So whenever an equation has as its solution set the empty set, you refer to that equation, you classify it as a contradiction. All right, here's another special type equation. Of course, I start this off by distributing. Notice that the minus in front of the parens is really taking the place of a -1. When I distribute the -1 there, I get the opposite of x, and I get a -7. When I collect like terms, the left-hand side becomes 2x minus 7. That's equal to 2x minus 7. When I move things around, which to be honest I don't even have to do here, but let's pretend we did, I get down to 0 equals 0. Now, obviously this is a special case because your variables have dropped out. And if I asked you the question, when is 0 equal to 0, I would hope you would tell me always. Well, that means this equation is always true. So what that's telling me is any real number I plug in for x will work. Therefore, the solution set is all real numbers. And the equation itself is classified as an identity. Anytime an equation is an identity, the solution set will be all real numbers. And the reason that identity term is used is, look up here, the left-hand side is identical to the right-hand side. The solution set of an identity is all reals. Okay, the last problem here, I'm actually going to do this on a separate video. So I'm going to end the last video, and you can tune into the next video to see the solution to this linear models problem.